over a century, cars have made our world go round. We've built billions of them. Thanks to evolving technology, they're made quicker and more intricately than ever before.
But this is the latest state-of-the-art factory. It is an amazing place.
A lot of different jobs, very little space in there for error.
Nowhere are the stakes higher than in the world of luxury and bespoke cars.
It was the biggest gig in the automotive industry.
In this series, we'll see iconic cars built from scratch, from bare metal to finished product.
All the little bits that make it go boom.
Using high-tech robots.
We take something from our rich and wonderful heritage and reinvent it for the future use.
And clever techniques that are hundreds of years old.
It's very important to be instantly recognisable, and we want them to live on forever, if you like.
This time, the first all-electric version of the classic British Mini.
Instantly recognisable and true to its origins.
Built at the Oxford plant in Britain, it'll need a chassis, electric motor, paint job, interior, and thousands of individual parts all put together perfectly.
If we don't get the quality right here, it's really going to be hard to get the quality right further down the assembly process.
Before every component is inspected to make sure it's ready to power up on the tight schedule.
And that's it. The big high-voltage battery is assembled to the car.
This is how to build British, an electric Mini. The new Mini Electric is the latest incarnation of a true British icon.
If we look at the Mini Electric, we are pure Oxford, born and bred.
Taking the original's retro aesthetics and giving them a modern twist, the concept was trialled in 2008 for today's changing car climate.
The dream of emission-free driving has already become reality. Making its world premiere, the Mini E.
In 2019, domestic transport was producing 27% of the UK's total greenhouse gases, the equivalent of 122 million tonnes of CO2. With pressure mounting globally for carbon-neutral cars, the UK government plans to ban the sale of most new diesel and petrol vehicles from 2030. And both customers and manufacturers are responding.
We are very proud to produce a new electric Mini here since 2020. Electrification is getting more and more important for us, and so it's a great honor to build the full electric Mini here in Blunt, Oxford.
The challenge now is that the demand is there, and we're now building more than ever. So for every 2 combustion engine we build, we're building an electric.
In 2020, over 100,000 electric vehicles were sold in the UK. When hybrids are included, they represent 17.5% of all sales.
We're constantly increasing the volume, and currently we build roughly 250 electric Minis a day.
But changing an industry that's been fueled by oil for over a century is a major economic U-turn. Car buyers of the future may need to make changes, but the car makers have to redesign their whole business.
We were really proud that we were the first manufacturer to integrate a fully electric car into our normal lines, where sometimes you would just build a new plant or create a complete new facilities, and it's still done in the same cycle time and in sequence feeding into our main line. So that was one of the challenges, definitely.
I think in the future we will be looking to build all electric engines, because that is the future, obviously, and we're well prepared for that.
The Cowley manufacturing site can trace its history back to 1912 and Mini to 1959 at the site here. It's been producing the modern Mini for 20 years, and over 5 million have been built since. But the new electric version has brought in change.
There were some challenges how to integrate a fully electric car in a combustion line. So one example is that we built the engine in the same line as we do the combustion engines, but no part is the same, no process is the same.
The car we'll follow is being made for export and adventures on mainland Europe. The customer has specified a chilly red paint job with signature black contrast roof, 17-inch alloy wheels in black, a panoramic sunroof, black interior, and of course, that all-electric powertrain. If you were buying this in Britain, it would cost £28,000 after the UK government plug-in grant. The heart of the operation is the assembly line, where around 2,000 people work. Here, all of the elements of the car, from the engine and doors to painted bodies, enter from around the 100-acre site, and finished cars leave after 39.5 hours. Each car accumulating around 2,500 individual parts along the way. But before the bodywork begins at the Cowley plant in Oxfordshire, the body shell is pressed just over 30 miles away in Swindon. And in just under 40 hours, the materials that Matt is about to transform will make up the skeleton of a completed cutting-edge electric car.
If you look behind me, you see some raw material in the form of coils. These coils range from 5 tonne up to 23 tonne, depending on what part we're running at the time.
Coils of steel like these will be used to make up every one of the structural and surface panels of our car. Right now, the team are starting the production of the A-pillar.
When you open your door, you'll see a pillar running down. It's a strengthening component on the car.
Each steel component is made from a pre-cut shape, but before these can be stamped, the rolls of metal must be prepared.
As you can see, the coil is tightly wound, so we run it through the feed line, through a series of washing machines to clean the metal, and then through our levelers, which flattens the metal, ready for it to be stamped. Here we can see a loop pit. The metal travels down the loop pit and comes up the other side. This just takes the tension out of the metal for when it's feeding into the machine. Imagine if you're towing a car. If it's very tight, the tow tends to snap, and you can't have that. You've got a continuous flow into the press.
This sheet metal will be pushed to its limit when it goes through the presses later. So it's essential it has the correct lubrication.
Green is good. Blue is getting a little bit dry. And the reason we put oil on is twofold. One, protects from corrosion when it's being stored. Secondly, when it's going through the press, through the draw die, it helps the metal stretch a little bit. If the metal's too dry, we just split.
Now it's ready to be stamped into the correct shapes.
Inside the press is the tool for this specific part. We have about 160 different tools that cover every part of the Mini, from roofs to bonnets to tailgates, etc. The press is currently running at 40 shots per minute. The maximum for this press is about 45.
Clever automation means that more Mini parts can be made every day.
One day we can produce up to 20,000 blanks using a 3-man team.
With so many parts stamped every day, production is regularly checked.
When we run out of skin panels, they have to be placed on this table, stoned up to show any imperfections in the metal before we send it to the press lines. Skins are absolutely critical. They have to be pimple and ding free. If I find one blank like that, we'll isolate the whole coil and immediately take it off the machine and quarantine it, and then search backwards to the beginning of the process.
Right now, the chassis parts are just flat panels, so the next process is to turn them into the 3-dimensional shapes required. This is done in a series of huge presses which use a set of unique molds or dies to make each part.
This is the left-hand body side, so this is where the pressed steel is formed.
The car may be mini, but the tools needed to press its panels are definitely not.
The heaviest we see in here is about 33 tonnes. Obviously, it depends on the size of the panel, and like the roofs, it's going to be a very heavy tool.
Because these huge tools exert forces of over 2,500 tonnes, Owen is part of a team at Mini that takes care of them.
Of course, it's vital maintenance to look after these tools because this is the starting point, really. It's pretty amazing that you think you could be working on one of these tools and then you can see the panels that are on the cars.
With the dies freshly serviced, Bernie takes over the pressing of our car's parts.
These are the blanks that you've just seen pressed on CB7. This is enough blanks for our batch. Batch is on average about 2 hours. This is our core process, taking the blanks that we've produced into panels through the forming operations.
In order to make our Mini, Bernie is getting some heavyweight help. This state-of-the-art press is one of the biggest machines used in the manufacture of our car.
After the blanks are loaded into the line, they then just go into the destacking station. It's really important that we only load one blank into the machine at a time. We have fan-out magnets which go up against the stacks of material. They separate the blanks from each other. With the oil coating, they sometimes stick together. We have various sensors, so if a double blank does go in there, it's detected and rejected.
With a single blank sheet selected, the pressing process can begin.
The main forces are in the draw die. The press is a 2,500 ton servo drive press with a 300 ton cushion. It's trapped with the cushion and the pins, and then it's formed over the top of the punch coming through it. That's why this is the most complex die.
As the part moves along the line of presses, each stage performs more reshaping and cuts. It's a fast and efficient way to make extremely complex components.
The press can run at speeds of up to 18 strokes a minute, and we look to run a job for about 2 hours, which just gives us enough time to prepare the next job.
There are over 300 different body parts pressed here, and every batch is thoroughly inspected before leaving the press shop.
These are the A-pillars which will go into the Mini, which you'll see assembled in Oxford.
All the parts may be pressed, so now our Mini Electric needs putting together. Its body in white needs to be built from the ground up.
On average, we apply 885,000 studs per week.
It needs painting.
It's the colour which brings the personality, I think.
And an electric powertrain fitting.
The electric engine has a lot more connections than a combustion engine would.
With its delivery to Europe imminent, the clock is ticking. We're following the build of an all-electric Mini from rolls of raw steel into a 21st century car.
We're constantly looking for different ways to bring that individualism to the product.
But the car we see today is the product of over 60 years of evolution. The original Mini was created in response to the 1956 Suez fuel crisis. Fuel rationing was in place across the country, and Brits needed a car that was affordable and economical. British designer Alec Isagonis was the man tasked with the job. He had a very specific brief. The car would have 2 doors, hold 4 people, and must be able to fit in a box measuring 10 by 4 by 4 feet. After several prototypes, the Mark I Mini was born.
In 1959, along came the white car, the Mini. Isagonis designed, drew the basic shell, brought it forward, turning the engine through 90 degrees so we didn't have the tunnel of the prop shaft or the exhaust going through the middle to save space in the internal compartment, moving all of the 4 wheels to their furthest outside elements, again not intruding into the interior side, gave us the Mini, something which at the time ticked the boxes. It ticked the box of comfort. You could get 4 people in there with all of the luggage. There was no electric windows or anything like that. It was basic in that sense, but it served a purpose, very economical.
Initial sales were slow, but the Mini cemented its reputation on the racetrack. Under the supervision of Formula One team owner and racing legend John Cooper, the Mini received a more powerful engine, sharper steering and bigger brakes. In the summer of 1961, the Mini Cooper was born. This punchy little car went on to win the Monte Carlo Rally on 3 separate occasions and is still being raced by privateers to this day. Since then, the Mini has featured in countless films, TV programs and photo shoots, becoming a British pop culture icon when it starred in a classic 1969 movie.
The initial high point would have been the Italian Job film with Michael Caine. If you look in the background, you will see a car that has been signed on the bonnet by Michael Caine himself.
Throughout this illustrious history, one thing has remained constant.
So if we look at the Minis globally, all of the 3-door, the 5-door and the Clubman all come from Oxford, all 100% Oxford. And if we look at the Mini Electric, we are pure Oxford, born and bred.
So far, we've seen our car's chassis components cut and pressed at the company's production base in Swindon. But now all the pieces have been transported to Mini's historic home at the Cowley plant in Oxford.
Over here is where you can see that all of our logistics supply directly from Swindon arrive within Body in White.
Based in its own build hall, our car's chassis is about to take shape.
What we're going to look at now is really the start of the Mini within Body in White, so the front end, the rear end and the underframe and how that comes together. Within this process, we ship a completed rear end every 60 seconds.
The chassis build begins by assembling the base of the structure.
So what we have here are two of the standalone electric Mini cells that we have within Body in White. And here what we build is the seat pan and the rear end.
Bodies in white for both combustion engine and electric Minis are made here. But because an electric car is very different under the bonnet, the chassis are different too.
The seat pan, which is unique for the electric Mini, goes into the rear end. As you can see here, they join together within this one cell, and then the rear end, when it's completed, will then go into our existing facility, which will then go into our overhead system. The start of the process really is when we load up the single part assemblies into the load stations. We'll then have the robots which will then join the single parts together.
These sections are the foundation of the car, so checks are performed early on to ensure the structure is solid.
We do a variety of weld checks within our product just to confirm our weld integrity.
An ultrasonic scan, similar to that used on pregnant women, is used to guarantee the workmanship of these robots. There are over 900 of them in this facility alone, but they can't do everything.
We have a very complex production system within Body in White, but in order for that to work, we have a very skilled workforce, which comprises of our production associates, our maintenance teams, our technical lead associates that oversee the teams. So all those elements mixed in with the actual automation of Body in White, enables us to produce a good quality product every time.
With the underbody complete, our car build can really take shape.
So this is really the first place in the body shop where you'll see the bare metal components actually look like a car body. You can see the front end and rear end drop down the lifter, and then separately the main floor as the third component drops in its own lifter. These are then married together through spot welding processes in the underframe geo facility, and you can actually see the car start to look like a true car.
Modern car bodies are manufactured using a variety of processes tailored to maximize the vehicle's performance, so it's not simply a case of just welding the parts together.
It is spot welding across the body shop. It's also adaptive spot welding, so it adapts to the thickness of the metal for the heat, temperature, current that it needs to be passed through to ensure that we get the most substantially high quality weld.
And even adaptive welding isn't right for fixing every part.
The number of gluing processes that are used across the Body in White process chain. The glue is used to basically bridge the gap between some of the panels, especially some of the thinner panels, single skin panels in the process, to remove flutter or vibration in the panels when it goes to the customer.
With our chassis almost complete, it's measured for structural accuracy because every component added throughout the build will need to fit perfectly.
If we don't get the quality right here, it's really going to be hard to get the quality right anywhere further down the Body in White or paint or assembly process. So the same robots, following the same programming method, but they've just got a different measurement head on the end of them instead of a welding gun. That measurement software is then fed back through the robot to this Perceptron software. We're talking less than millimetres sometimes.
With our chassis given the green light, these very modern machines turn prehistoric.
Strangely enough, there's a sort of local internal Body in White nickname for it known Jurassic Park. It's got some yellow safety framing gates inside that look like they are from Jurassic Park holding some sort of dinosaur in.
And there's a good reason these riveting robots are kept behind bars.
On average, for the full volume week, we apply 885,000 studs per week. These are fitted across the underframe of the body, the rear end, front end and main floor. It's an anchor point, a fitting point for many different things, wiring looms, bracketry, a number of things in the assembly lines.
While the chassis is built, the car sides are taking shape too.
We now have three main components that are then fit on top of each other to turn the Body in White material into what looks like a true car body.
Outside the robot cages, it's a human team supplying the parts.
And you can see the turntables for the different model types, including the electric vehicle, which rotate round and load the different load stations for the manual operations to then take place, loading the small components which make up the side frame inner.
And when all the sections are ready to assemble, the whole process really picks up speed.
So what we've got on is what's known as a high-speed shuttle. So it's a belt-driven shuttle with carriages that lift up to the underframe and drive at a very high speed down the line. This is to support in the cycle time and the reduced cycle time of the process being at about 60 seconds per vehicle.
Last to be added are all the car closures.
All the bolt-on parts or hang-on parts are fitted to the vehicle, so rear doors, front doors, bonnets, tailgates and fenders. What we can see is a BEV or a battery electric vehicle coming down the line on its final process in body and white, doing its final buy-off check. It'll then go on from here, up the lift station, into the body store and onto the paint shop.
After 9.5 hours, our body in white is complete. But the owner of our car hasn't ordered a white Mini, so it's time to brighten things up. It's just a short journey into the next building, and our car begins its paint preparation process, which starts with a good clean.
Pre-treatment involves 3 chemical processes. The first one is called degreasing. The bodies that you can see are coming from a body in white. They are covered in oil layer. Pre-treatment consists of 15 tanks and 2.5 million liters of fluids. And the bodies are submerged in them.
Our car will be one of almost 1,000 passing through the paint shop every day. And now it's cleaned, it's time for its first protective coat.
Next, the bodies are going to have the application of zinc phosphate coating, and at the end the body shells are submerged into a dip tank when an electrocoat is going to be applied. It's a paint electrically charged. The electrocoat is drawn to the body and it builds a protective layer. The main task of a treatment is to ensure that the car are protected from corroding.
The metal chassis may be protected, but before painting can begin, all the gaps and holes need to be filled.
After the electrocoat has been applied, there's still some areas, like the corners of the panels, that are still weak and prone to corroding. That's why we apply a layer of mastic sealer to those areas to protect them from corroding. Associates are fixing the car with different handles, so when the body goes through different processes, different panels can be opened and the sealer can be injected in those areas.
Sealing is done both robotically and by hand in the harder-to-reach places.
After the bodies have been through all the stations, bodies are ready to go to SimSeal oven, where they are baked for 20 minutes at a temperature between 170 and 190 degrees.
The chassis are then inspected and blemishes are corrected before receiving a final feather dusting.
We use ostrich feathers. They are electrostatically charged, so the loose debris hold on to them. That's why there are no contamination on the cars, no fibers, no dirt, no dust. We use the female feathers. As in the wild, males are usually fighting and damaging their feathers. The quality of female feathers is better for this purpose.
Finally, our body is ready to be spiced up with some color. And it's chili red in this Mini recipe.
We are using the ESTA robots, the electrostatic application. To simply put it, the body is like a magnet. So the fingers that you see around the head of the robots are electrostatically charging the paint particles, and they're attracted to the body.
These robotic teams can apply a coat of paint in under 2 minutes, and multiple coats are required to keep the car looking good for longer.
We apply 3 layers of paint. Base coat 1 is the first laydown of paint, and it protects the car against the UV light. Base coat 2 gives the designated color to the vehicles. It gives the depth to the color and the sparkle to the metallic variations of the bodies. Then subsequently we put clear coat. Clear coat is the hardest material. It protects the body against contact with chemicals like acid rain or bird droppings, and it actually gives that shiny finish and the smoothness to the car.
For a Mini like our car, though, the paint job isn't done yet.
Some customers are increasingly wanting more and more customization and individualization, and we're constantly looking for different ways to bring that individualism to the product. In 2001, when the new Mini was first launched, we had only body-coloured roofs, and we very quickly got strong demand from customers and from dealers about classic Mini, which had the red body, white roof.
With a nod to its long heritage, the character of our car is definitely colourful.
It's the colour which brings the personality, I think, to the product. And yeah, we've got 14 colours at the moment, which the customers can choose from, in combination with 4 different colour roofs to bring a contrast. We bring colours in and out each year, so we're constantly updating the colour palette. And we really were the first to go with, in a modern era, a contrast roof. Others, of course, have followed.
Our car's chilly red body is getting topped off with its own black contrast roof.
As you can see, associates now are applying a masking material around the car, as when we are spraying the roof, the color from the roof may land on the body and cause an overspray.
With the black roof added, the whole paint job gets one last inspection.
The lights are very important. It's because the car has to be well lit, and in order for the quality inspectors to look for the faults. From the moment when the body enters the pretreatment area and it goes through all the processes, it takes over 7 hours, including the application of contrast roof, for the car to be finished.
Our body may be painted, but the deadline is looming to get the car completed. It still needs its powertrain installed.
We use the same station for combustion and electric engines.
And interior fitted. And the whole package must be assembled in time. We're following the build from start to finish of a new Mini Electric. We've seen the body built.
And you can actually see the car start to look like a true car.
And painted with a contrast roof.
And we really were the first to go with, in a modern era, a contrast roof.
But our car still looks like this, a shiny shell waiting for its powertrain and interior. The centre of the build process for our car is the assembly line of the historic Mini Oxford plant in Cowley.
We're currently in the assembly building. This is, I would call, the heart where you see the Mini is made customer specific with all the options, whatever the customer chooses.
Inside this 80,000 square metre building, our painted Mini shell will be transformed into a finished car.
We have about 250 workstations in here, and we build around 1,000 cars a day in 3 shifts operation. So it's a massive building.
There's lots still left to do and not much time.
It's roughly 6 hours from the first process and assembly until the car is ready to drive off. The cycle time is a little bit above a minute, so 67 seconds precisely. We have a little bit over 600 associates per shift building those cars, 3 shifts a day. Assembly is mainly human-driven. It's about all the small processes, a lot of options for each car. But we do have automation as well. So if we need to lift a big engine or engage unit into a car and need to do a lot of fixings on that, that is what we have automated.
The assembly begins on our car when it arrives from the paint shop. The first job is to give the body its unique VIN number.
The car gets its first identification, its legal requirements in all the different countries. You'll see that we check the quality of the stamp and then we cover it with the foil to make sure that there's no corrosion can happen underneath.
The doors from our car are removed to be built up separately, and the body is transported to the start of the assembly line.
In the background you see the wire harness fits, all the cables throughout the car, so it comes in one big package. And over many, many stations, it's distributed in all different areas.
These cables link all the electronics of the car, helping control everything from the electric windows to the headlamps.
It's customer specific, so depending on what options you have, so it's made in sequence by a supplier for us, and then it's really distributed.
On a separate sub-assembly line, the dashboard or cockpit for our car is being assembled. Once completed, the dashboards are automatically transported to the main assembly line by their robotic AGV helpers.
We use them to bring our own pre-assemblies to the fit point. They are safe, so if I would approach them, they would stop. Now he's complaining probably, so I rather go away and let him go again.
With the dashboards delivered, they are ready to be installed.
It is a big unit, it is heavy, you want to do it precisely, and you use that device to get it in the correct position.
And with the cockpit installed, standard and customer-specific options can be added.
To finish up, it needs all the components. You see the toggle switches to start and stop your car. And those come in sequence in car kits, individually for each car and model.
Next, the cars are transferred onto a special assembly line so work can continue on the bottom of the vehicle.
So in the background, you see the car dropping down and turning. To that, you see the orange high voltage cables and the perfect access to the underbody. We are now in an automated cell. It's the so-called rear marriage positioning or fittings, where the rear axle will be installed after it's pre-assembled in the pre-assembly lines. So this will be engaged into the car, and then it will be transferred without a sling into a robot station where we do the bolting. So all the rear axle bolts will be automatically tightened by robots.
And of course, it's not just electric cars like ours that need to be made on this assembly line.
All different variants depending on the type model we build. We do build four-wheel drive cars and we build two-wheel drive cars. So people work in the rotary on both sides. Most of the content is on the other body, but we do have some content on the roof, like the roof fin, antenna.
With the work completed on the tops and bottoms of the cars, they're transferred back onto the normal assembly line. Robots take over building here, so they need to know which car they're working on.
We have tags on the car, if you see them. They have the data for all the cars, so it moves with the car. And that's where we know in the sequence then which car is in which position. Depending on the car, we have pre-assembly areas for that as well, where the right class is prepared. And finally, the robot has the right program to put it in the right position.
With all the information they need, the robots can start to fit the windows.
So there is a robot to pick up the glass. It will apply then the glue on the glass, and finally it's stacking the glass to the car. So this is a really precise process, and it's heavy weight, so that's why it's automated.
With our car fully glazed, it's ready to receive its electric powertrain, which is being assembled in another part of the main assembly hall. Mini were the first car manufacturer to use the same production line for both electric and fossil fuel-powered vehicles.
This is the electric motor. Okay, it comes with HV cables and a gearbox attached with some of the heat covers. All the internal components are already pre-assembled, all ready for us to load. We will then load the engine and then fit various components that are within our engine lines.
These BEV, or battery electric vehicle motors, need a bit more protection than their fossil fuel cousins.
This is the actual E-frame that protects the actual E-motor. Once it's assembled, it basically sits on top of the E-motor, so it protects it. It's like a guard around there.
In addition to protecting components, this cage is also specially designed so the smaller electric motor can not only travel the same assembly line as the traditional engines, but fit the Mini chassis too. It's then ready to be assembled with its powertrain.
So this is an E-motor at the end of line 3. When it reaches here, it's had his right hand, it's had the left hand drive shaft fitted, it's had his UCX box fitted, HV cables fitted. It's had a number of coolant hose connections made.
Building a BEV drivetrain is very different from the other engines on this line.
An electric engine has a lot more connections than a combustion engine would. In fact, there's 32 hoses with a total of 64 connections made.
While the electric motor is dressed, the subframe is prepared on a different line in preparation for the motor to be mounted.
So this is where the engine or E-frame is loaded to the subframe onto the plat and ready to move on to line 5.
With the motor loaded to the subframe, we are ready to set up the gearbox and connect the two elements together.
On an electric, at this station here, we would actually carry out the tooth-on-tooth positioner. So it's an electrical component which we plug into the actual harness on the E-motor, and that actually internally sets the gearbox up.
With the motor firmly attached to the subframe, it's time to fit the coolant system.
So this is where we fit the radiator or coolant module. As obviously it's a coolant-based system, we still have to fit a front coolant module, whether it's a combustion or an electric.
Although electric cars don't burn fuel, their batteries do get hot, so the cooling system is still essential. Helpful robots are on hand to give every drivetrain the once-over.
These robots take a number of images, whether it's a combustion or an electric. It's checking for various components. Once it's carried out its check, it gives an OK result, ready for it to move on the track. The engine will then move on, go upstairs, and it will drop back down where it's ready to be married to the body.
Back on the production line, all the bits to help our Mini move are about to join our car.
We are now in the front marriage, so where the engaged unit of motor, engine, gearbox and front axle gets assembled into the car. We use the same station for combustion and electric engine.
This process is traditionally called engine marriage, but with fossil fuel and electric powertrains on the same assembly line, the process must be carefully monitored.
First, we do check in a camera station if all parts are in the correct position for getting it into the body. It's really tight tolerances, so just a few mil.
With the powertrain in position, the robots ensure it's securely fastened.
Now it's in the right position. All the axle bolts will be done. So they turn all green if all the tightenings have been done. So you see it's 8 tightenings. So the left side is done.
But our car isn't going anywhere without its batteries, which are the final component to be added in the marriage station.
Now you see that's a pre-alignment, so the pins come up to align the whole thing against the body, and now the final lift and the fastening happens. And that's it. The big high voltage battery is assembled to the car, so the empty lift table comes down and the car will proceed into the next station.
Our Mini may have its body and powertrain built.
Since it has a huge high voltage battery, this needs to be chilled or cooled as well.
But there is still a lot left to do before this car is ready to drive. And the clock is ticking. Our Mini may have a body and motor,
and now the final lift and the fastening happens.
But it's far from finished, and the delivery deadline is looming. Our car is just over 60% of the way along the 3-kilometer production line in the main assembly hall. It has most of its body attached, but it's still missing that distinctive Mini face.
Behind me you see the front end, which is a supplied part component, and we will assemble that with a handlings device in the line.
The Mini may have grown in size over the years, but it's still unmistakably a Mini.
So the new Mini, new designed front end, front bumpers, integrating crash bars and body coloured coding. The new wheel arch batch, which gives it true definition and define elements within the new Mini range. The new design of the side scuttles for the new lights. The yellow denoting the electric vehicle, but it's got the S, so it still gives it the sporty, punchy function with it. The contrast roof, still very, very popular. Tail lights and the new black chroming clusters, which gives it more of a sporty, aggressive feel. The new bumper designs, the new aerofoil designs underneath, new sports designs. Instantly recognisable and true to its origins, true British.
Next installed on the assembly line, the all-important seats.
First, we get the rear seats into the car because you still need the access to get it, especially on a two-door car. That's this drop section. So the seats come down from a conveyor system, be picked up and installed into the car. The front seats will drop down here, and this is for each side individually. So both come down, one gets picked up for the right side, and then the system goes up again with a conveyor onto the other side, and the left-hand side will be installed.
And then 4 more items go onto our car before it can finally be put on the ground.
Behind me you see the wheels on process, where we install all 4 wheels of the car before it finally drops on the sled lines. Above the line it's split into left and right side, front and rear, and then they drop down in that conveyor behind me. You see then the handlings device where we pick up the wheel and assemble it to the car. It gets a pre-fixing, and then finally you see those 5-spindle nut runner. So that will be just attached to the car, and then it completes the job by itself.
The last major parts to install are the doors, which were built up on their own assembly line. It's time to put those chilly red doors on.
We have chosen a late point of install because we always want to get that access, and you can imagine with the doors it's not so easy. You need to open and close them. All the doors after the pre-assembly are stored in an overhead conveyor system, waiting for the right car to come back online.
Our car is now on the final stretch of the build. And because it's electric, it gets a different treatment from the more traditional Minis built here.
It's one of the last lines in assembly. You can name it the filling line. This is where the car is built and now gets all the media, like fuel.
Our electric car may not need fuel, but it still needs some fluids.
Since it has a huge high voltage battery, this needs to be chilled or cooled as well. So it's connected to the cooling circuit of the car, and it gets a lot more coolant. So the filling time of an electric car is longer than from a normal combustion car.
Our car may be through the finish line of its build, but it still has a raft of tests and checks to face before it's ready to head to its new home in Europe.
We are the area here where we test the car. It's called a rigs and rollers.
The first part of the test is to check the headlight and wheel alignments. Next, our Mini is taken to around 150 kilometers per hour on rollers to make sure the motor and gearbox are functioning properly.
So after the rollers, obviously goes to the next station, which is the ABS. And there we mainly check if the car has got brakes and the handbrakes works as should be.
Then it's ready to be let loose on the factory's indoor testing circuit. A mini track for a mini car. But don't scratch it, because the team here will spot even the smallest fault.
It's the final buy-off where we do check the outer surfaces, any potential issues with the car before we ship it then to our transport.
After 39.5 hours, our car is complete and ready to make its escape from the factory. While the rest of Oxford sleeps, Minis are on the move. The man in charge of getting our car across the border and into Europe is Andrew.
We're dealing with 1,000 cars a day. The team in dispatch are behind the scenes setting where all these cars are heading out.
Not all the cars are heading to Europe. About 20% will stay within the UK.
Gareth over here, he's currently loading up. He'll be putting 12 Minis on and then taking them sort of steady drive up to Immingham.
But with Minis being exported to over 100 different countries, our electric car is taking the eco option.
For sustainability, what we try to do is send as many out by train.
It's a tight squeeze, but Minis have been doing this for years.
Yeah, as you see, the cars come in, it's very, very tight. New starters, if they're driving on the train, they tend to duck, you know, because it is so low.
Here comes our car now, going undercover on a choo-choo.
Nobody really knows actually what's in it, so of course it keeps the car nice and safe until it gets to the destination at Southampton.
It won't be staying in the UK for long, though, and as Michael Caine once said, in this country they drive on the wrong side of the road.
I believe it's actually going to Italy, so that will head down to Southampton. It will leave us this afternoon, and within a couple of days it will be on a ferry and on its way, ready for the customer to receive it.